Hello everyone, my name is Wu Pengfei. I'm currently being a PhD candidate in the Department of Real Estate and Construction, the University of Hong Kong. My primary supervisor is Professor Wilson Liu, and my co-supervisor is Dr. Frank Xue. Today, I will talk about blockchain-based smart contract for smart payment in construction, a focus on the payment freezing and disbursement circle. So I split up the presentation into 7 parts. Section A, payment in construction. Section B, blockchain and smart contracts. Section C, research aim and objectives. Section D, a blockchain-based smart contract framework for smart payment. Section E, sixth architecture. Section F, a prototype system. Last section, prospects and challenges. Section A, payment in construction. So payment refers to the act whereby one party provides value, discharge, or compensation to another party for the goods exchange or the service rendered according to the pre-agreed terms. Although payment disputes are inevitable in our daily life, construction is actually labeled as a business sector that is suffering one of the worst payment records. Unlike manufacturing products that are designed, produced, and sold off the shelf, and upon then recovered the prepaid cost by the producers, construction products like a building are bespoke by the clients and often involve huge prepaid costs for materials, machinery, and workforce that are too burdensome to be carried by the contractors for too long. So the construction industry has its own characteristics in terms of payment. The first one is progress payment is really adopted to reimburse the contractors for their works completed within a time period rather than waiting for the end of the project. And secondly, the progress payment is further paid through a cascading mode. For example, the project client to the main contractor and the main contractor to the subcontractors and so on down the chain. And thirdly, it is common to place intention to allow for the circumstance when work has not been conducted on time or correctly. So a typical progress payment cycle in construction involves 4 stages, such as payment initiation, validation, finalization, and disbursement. And the late payment is actually very serious in the construction industry. For example, the UK construction industry has shown an upward trend in amounts owed to contractors, with late payments doubling in value from USD 26 billion in 2008 to USD 50.6 billion in 2012. As another example, a fairly large proportion of subcontractors here in Hong Kong, like 57%, they considered late payment problem in construction projects as very serious. And similarly, unpaid errors represented more than half of the Chinese construction industry's profit and accounted for as much as 15% of the industry's total production. So there are lots of reasons that can cause late progress payment in construction. For example, the inefficient fund owned by the clients, which basically means they don't have enough money. Another reason is simply because the disagreements among different construction stakeholders on progress evaluations and variation audits. The third reason could be because of the complicated process of the payment process or the payment system. On top of that, power imbalance in construction supply chain stakeholder relationships can also cause late progress payment. So the late payment may bring significant negative impacts on the construction stakeholders. It may bring cash flow problems to the construction stakeholders. It can also result in the inability to pay wages, further leading to lengthy project delays and adversary relationships between parties. Moreover, it may tarnish the image of project participants. Also, it may bring difficulties in acquiring funds from financial institutions, such as banks. Section B, I will introduce the basics of blockchain and smart contracts. So what is blockchain? By definition, blockchain refers to a distributed ledger with cryptography and decentralized consensus mechanism. So a blockchain has three key components. The first component is consensus, which is a method of authenticating and validating a value or transaction on a blockchain without the need to trust a third party. The second component is called cryptography, which is hash algorithm to help us to ensure the immutability of the recorded transaction information. The third component is distributed database, which is mainly composed of the ledgers and is achieved through a decentralized network. So what is smart contract? Smart contract actually be perceived as a great advancement in blockchain technology, in which the execution of contract terms can be performed on the blockchain with self-executed computerized protocols. So it has two major components: the predefined conditions and the predefined responses to be performed when the predefined conditions are met. A smart contract has a life cycle from initialization to configuration, from configuration to self-execution, and finally to completion. So the applications of smart contract have actually started to emerge in the construction industry. They have been used for fail change recording, document management, compliance check, BIM modification auditing, invoke and update operations in blockchain networks. And also studies using smart contracts have also been observed for smart payment in construction. They have been used for payment efficiency by increasing the payment efficiency. Also for payment automation, fund security, and decentralization of execution of payment terms. So all of these studies have actually made significant contributions to improve the late payment problem in construction. And however, the problem domain is still too complicated, which requires us to further study. In section C, I will outline our research aim and objectives. So in our proposed published journal article, we said we aim to develop a blockchain-based smart contract system in order to improve the late payment problem in construction by focusing on the payment freezing and disbursement circuit. So basically, we have three specific objectives. The first objective is to establish a BBSC framework as a reference for smart payment in construction. Objective 2 is to validate the framework by proposing a system architecture of the framework. Objective 3 is to develop the prototype system by implementing the system architecture in a case study. So in section D, I will talk about our proposed framework. So the framework was developed by combining the smart contract life cycle and the real life scenarios of progress payment in construction. It has three parts. The first part is initialization and configuration. Second part is payment freezing. And third part is disbursement. So remember, this process actually happened on the blockchain-based system. So in order to develop a system, we need to design the data frame structure. So as you can see from the figure here, the data frame includes a key value pile. The key indicates the payment stage, and the value indicates the detailed payment information. So it also includes the time steps, hash value, signature, and previous hash value. So we also need to write the conditions of the smart contract for each of this payment freezing stage, as well as the disbursement application stage. And also we need to write the predefined response for each of these conditions. So when the condition is satisfied, the smart contract will trigger the response automatically. And also, once the transaction is occurred, it will be included into the block. And in our proposed system, we did not get rid of the banks, unlike many other studies. The reason is because we believe that the bank is not the major cause of the late payment in the process. And we'll also talk about this lately. So in order to develop a fully operable system, we need to carefully design the sequence of the payment freezing and disbursement process. So this figure actually indicates the sequence of each of this process. So simply speaking, when you do the payment freezing request or submit the disbursement application request, then the smart contract will check the conditions, and depends on the check results, it will trigger the corresponding responses. So in section E, I will talk about the system architecture of our proposed framework. So the system architecture has 3 layers from the bottom to the top. It's infrastructure as a service, blockchain as a service, and software as a service. In section F, I will talk about the details of the prototype system. So in the prototype system, when it comes to the first layer, we have 3 applications. The first application is the web-based user input application, which helps the users to submit the payment freezing request or the disbursement request. The second application is a project management application, which can help users to determine the estimated progress payment and the actual cost. The third application is a mobile-based inspection applications, which helps the users to actually check the quality of the constructions. And the second layer involves 2 smart contracts. It also involves all the stakeholders that should be added to the blockchain network. And also we created 2 channels, 1 channel for payment freezing and 1 channel for disbursement. The third layer involves a consensus mechanism. And we also configured the digital wallets for each of the parties in order to make the transactions and payments. So our solution actually addressed several challenges. So for example, we addressed the low uncertainty of progress payment. We also solved the efficient paper-based payment applications, as well as the low efficient on-site inspection for payment validation. We also involved different applications in order to realize semi-automatic valuation and payment condition check. And finally, we try to use blockchain technology to decentralize payment mechanism. So in section J, we will talk about the prospects and challenges. So compared to other studies, we provided payment freezing solution. We also developed the mobile digital inspection applications to help with the on-site inspection for payment validations. On top of that, we also develop project management applications to help users to calculate the estimated progress payment and the actual cost. We also used a smart contract to check the payment conditions. And unlike many other studies, they use the cryptocurrencies, which may involve high exchange rates and unstable exchange rates. We involved tokens instead. Thereby, we can actually avoid the different exchange rates that suffered by the cryptocurrencies. So the hurdles to preventing such a payment system from actual implementation should not be underestimated. It would constitute an over-optimize to assume that a technology such as blockchain can easily disrupt the persistent payment problem in an old industry. And actually, some of the problems, they are caused by the current contract forms associated with the procurement model, such as design, bid, and build. So even with the decentralization nature, blockchain may be not effective because the change of the current cascading payment process or the hierarchy relationships among different parties cannot occur without changing the existing legal system. So it also may be infeasible to eliminate the role of banks. So if you look at the cryptocurrencies, people may trust more on the sovereign currencies and that are operated by banks. So if we use Bitcoins in the construction industry, people may have a huge concern about its exchange rates. So our development system can actually incompatible with the banks. The special ingredient is that banks no longer serve the clients only, but as a more impartial third party to facilitate payment between the payers and the payees. So in the future, we will try to develop a method for amending the smart contract in the blockchain-based network. Remember, blockchain is an immutable technology. So, but however, the construction industry always involves changes. So how to amend the smart contract on such immutable network is a big challenge. And also we will try to evaluate the impact of our proposed solution on the dynamics of project delivery methods. And also we will design an Oracle framework to connect the physical and cyber worlds in order to ensure the uploaded data to the blockchain is true. And finally, we will design a framework in order to help us or help the users to calculate the cost of our proposed solution. So this work was financially supported by the Hong Kong Innovation and Technology Commission with the Innovation and Technology Fund. And thank you very much for your listening.